Hello everyone, in this video I am going to give brief description of our project Medical Insurance Cost Prediction. I am Shivteja Khatrot and my team members are Yunis and Ablash. We are under guidance of Vice Chancellor Ma'am, Professor, Department of Information Technology. The main aim of the project is to predict health insurance costs based on various features of individuals using machine learning models by analyzing factors such as age, sex, BMI, number of children, smoking status, and region. The project seeks to understand factors affecting costs, build predictive models, evaluate model performance, optimize model parameters, and provide actionable insights. The overall goal is to leverage machine learning techniques to create a reliable tool for predicting insurance costs, which can be used to improve financial planning and risk assessment in the insurance industry. Contents: abstract, existing system, proposed system, system specification, literature survey, design and implementation. Abstract: this study focuses on predicting medical insurance costs using machine learning techniques, employing a dataset with attributes such as age, sex, BMI, number of children, smoking status, and region. Initial data analysis involved loading the dataset, identifying duplicate and missing values, and performing exploratory data analysis. Key insights were derived from visualization, revealing insignificant factors affecting medical costs, such as higher expenses associated with older age, smoking, and higher BMI, particularly among men. The dataset the dataset was preprocessed through label encoding and feature scaling, followed by splitting into training and testing sets. Three regression models, CatBoost, XGBoost, and Support Vector Regressor (SVR) were developed. Cross-validation and hyperparameter tuning using randomized search CV ensured optimal model performance. The CatBoost model and XGBoost model exhibited superior accuracy with R squared scores, indicating a strong fit for both training and testing data. The study concludes with practical predictions of insurance costs using the trained CatBoost and XGBoost models, highlighting their effectiveness in estimating medical expenses. This research demonstrates the potential of machine learning in providing accurate predictions of insurance costs, aiding insurance companies in risk assessment and policy pricing, while also offering insights into the factors driving healthcare expenses. And next one is existing system. The inability of typical ML algorithms to handle complicated data relationships and high dimensions is a common problem for existing medical insurance cost prediction systems, which could result in accuracy problems. Issues with data quality, such as biases and out of date information, also affect the fairness and dependability of models for varying demographic groups and the development of healthcare policies. Furthermore, advanced algorithms interpretability flows raise questions about raise questions about openness and undermine stakeholders' confidence in the procedures involved in making decisions. Next one is proposal system. The objective of the suggested method is to create a machine learning model for insurance cost prediction using characteristics related to health and demographics. The procedure starts with the data cleaning using the insurance.csv dataset to get rid of duplicates and dealing with missing information. Numerical parameters like age, BMI, and children are standardized, whereas categorical data like sex, region, and smoker status are encoded. To comprehend the distribution of the data and the connections between attributes and the insurance costs, extensive exploratory data analysis is carried out. Histograms, bar plots, and scatter plots are used to illustrate key findings and give a clear picture of how various factors affect medical expenditures. Regressions modeling is done by the system using CatBoost regressor, XGBoost regressor, and SVR. Randomized search CV is used to refine the models for best performance based on R-squared scores. Next one is system specification. Hardware requirements. In hardware requirements, processor i5 and above, 64-bit OS operating system, memory 4 GB RAM. Higher specs are recommended for high performance. Input devices, keyboard and mouse are input devices in ARM are input devices. Software requirements. In this project, we use Google Colab. You can also use Jupyter Notebook, but we use Google Colab. And next one is Python. Python libraries. In Python libraries, Pandas, NumPy, Matplotlib, Skitlearn. Literature survey. Literature, literature survey gives them previously proposed system, which we can see. These are the previously proposed systems. Here, by this, we can also say these are the existing systems. We can inspire from these existing systems and we can build new systems which required in daily life. Design phase. UML diagrams or design phase. Use case diagram. A use case diagram is a subset of a behavioral diagram, is a visual representation of the capabilities provided by the system with respect to the users, their objectives, and any interdependencies among these cases. Dependencies. Yeah. Next, class diagram. A class diagram is a type of static structural diagram that illustrates the relationship between the machine's actions, lessons, properties, and instructions to still show the machine's format. And next one is the activity diagram. This figure illustrates how information moves from one task to the next and is a more intricate version of a flowchart. It explains how different degrees of abstractions are reached by coordinating actions to provide a service. The next one is a deployment diagram. Here is the sequence diagram, and this is the architecture diagram, the architecture flow of the diagram. So this is the architecture diagram. Next, we will see implementation. Insurance.csv dataset. So we obtained the dataset from a Kaggle website. Dataset description, age of primary beneficiary, sex, insurance contractor, gender, that is male or female, BMI, body mass index providing an understanding of body weights that are relatively high or low relative to height, objective index of body weight, that is kg by meter square, kg by m square, using the ratio of height to weight, ideally 18.5 to 24.9. Children, number of children covered by health insurance, or number of dependents. Smoking, the one who smokes, yes or no. Region, the beneficiary residence area in the US, northeast, southeast, southwest, northwest. Charges, individual medical cost billed by health insurance. So this is our insurance.csv dataset description. Importing libraries. The code starts by importing necessary libraries such as Pandas, NumPy, Matplotlib, and Seaborn for data manipulation, analysis, and visualization. So, loading and analyzing the data. The insurance dataset is loaded into a Pandas data frame. The first and last few rows of the dataset are displayed to get an overview. So next, basic data information. The shape, data type, and summary information of the dataset are checked. Duplicate records are identified and removed. Missing values are checked. And it is confirmed that there are no missing values in the dataset. Next, categorical and numerical columns. Numerical and category columns are identified and listed here. Statistical measures. Descriptive statistics for numerical columns and values, counts for category columns are computed. Next, the data visualization. The code uses Seaborn and Matplotlib to visualize different aspects of the data. That is age distribution. A histogram of age distribution shows the concentration of ages in the dataset. Next, age versus charges. Here a bar plot shows how charges vary with age. Next is the sex distribution. Plot a count plot shows the number of male and female patients. Next one is sex versus charges. So a count plot shows the number of male and female patients. A bar plot shows the difference in medical charges between males and females. Next one is smoker distribution. So this is smoker distribution. A count plot shows the number of smokers and non-smokers. Next is the smoker versus charges. A bar plot shows the significant difference in charges between smokers and non-smokers. Next is the BMI distribution. A distribution plot shows the BMI values in the dataset. Next is the BMI versus charges. A scatter plot shows the relationship between BMI and charges for males and females. Next, it goes for children count. A count plot shows the number of children patients have. Next was the children's versus charges. A bar plot shows how charges vary with the number of children. Next one is the region distribution. A count plot shows the number of patients in each region. Next is the charges distribution. A distribution plot shows how charges are distributed. Next one, machine learning model. Machine learning model development. So category values are converted to numerical values using label encoding. Next, splitting data. The data set is split into training and testing sets. Next one is the future scaling. Numerical features, age, BMI, and children are scaled using standard scaler. Next one is the model training. So model training and evaluation, 3 regression models, that is CatBoost, XGBoost, and SVR, are trained and evaluated. So here is the cross validation. Cross validation is performed to access. Cross validation is performed to access the performance of the models. So model hyperparameter tuning. Hyperparameter tuning for CatBoost, XGBoost, and SVR are tuned using randomizer search CV. Next one is model training. So this is model training. The best parameters found from the tuning process are used to train the models. The model's performance is evaluated using R-squared scores for both the training and testing data. After that, a scatter plot with regression line. A scatter plot with regression line is created to visualize the actual versus predicted values for training data. So this is R square value, and this is a scatter plot with regression line. Same with XGBoost also, and same with SVR models. Predictions. Finally, here the code predicts the insurance cost for new patient with specific characteristics using the trained models. But CatBoost and XGBoost are performing well. They have good accuracy rate or R square rate comparing with SVR. So here the input data is taken: age, sex, BMI, children, smoker, region, and if male is 1, if male, then he should take 1, female equals to 0. Same with goes with this. And future scaling for new data. The future scaling, the new patient's age, BMI, and children's futures are scaled. After that, prediction. The prediction here is performed for both CatBoost and XGBoost models. The insurance cost is predicted using both the CatBoost and XGBoost models, and the results are printed. So the CAD-Boost and XGBoost models show good performance in predicting medical insurance costs, which CAD-Boost and XGBoost have slightly higher accuracy when compared to SVR. SVR is performing low level here. These models are effective in estimating. So CAD-Boost and XGBoost models are effective in estimating insurance charges based on the given futures, providing valuable insights for insurance companies. So thank you.